Hello students, in this video lecture we will discuss problem based on two-way classification in a randomized block design. Okay, we know what is meant by two-way classification. Two-way classification is nothing but we consider two different factor. One factor we consider row wise, another factor we consider column wise. Okay, so that is called a two-way classification. Let us consider one application. An experiment was designed to study the performance of four different detergents for cleaning fuel injector. The following data represents three different model of engine and four different detergents for cleaning fuel injectors. Okay, so here let us see the given problem satisfies two-way classification method. Why? Because here we are going to discuss what perform the ANOVA test at 0.01 level of significance, whether there are difference in the detergent and in the engines. Okay, so we consider one factor is column wise. Here we consider column wise is engine, three different model of engine, and another factor we consider detergent. So here we consider detergents are row wise. Okay, therefore this problem belongs to two-way classification in a randomized block design, otherwise ANOVA test 2. Okay. Solution. The given problem is two-way classification because one factor is engine and the other factor is detergents. Okay. So here we consider engine is column wise and detergent is we consider row wise. Okay. So now we shall subtract 50 from each value. Why we shall subtract 50 from given values means the given data is here we see the given data is two-digit number and also it is big value. Okay, so therefore we are going to apply coding data. What I mean by coding of data means the values of the samples are big. Okay, so we shall use the method of coding data to reduce the sample values. Okay, which means if we add a fixed number to all the observation, otherwise subtract a fixed number to all the observation, otherwise you multiply a fixed number to all the observation, or you divide a fixed number to all the observation. Okay, so we can choose any one operator, either addition operator or subtraction operator, multiplication operator, otherwise division. My suggestion is all of you should choose subtract operator only. So here how to choose this number is here from the given data we see the least number is 37, highest number is 55. Okay, we can choose any one number from 37 to 55 and we try to reduce two-digit number into single-digit number. Okay, so that I'm going to select the common number is 50. You can select 46 also, no problem. We get a same in final answer. We get same value. Okay, so this resulting data is known as coding of data, and the solution will not change. Okay, so that we shall subtract 50 from all the given observations. Okay, so for example we consider 45. What is 45 minus 50? Equal to minus 5. Okay, 43 minus 50 equal to minus 7. 51 minus 51. Okay, similarly we get a second row and third row and fourth row values. Okay, so here column wise we consider what engine, right? So the engines are nothing but different treatments, so we will assign different notations. One is x1, this is not x1, this is x2, and this is x3. Okay, once you get x1, x2, x3, then adding these values. Okay, once you add these values we get minus 18. Okay, which means sum of x1 equal to minus 18. Similarly, adding these values we get sum of x2, that is nothing but minus 24. Similarly, we get sum of x3. Sum of x3 value is 7. Okay, once you find the x1, x2, x3 values, next we take square of x1, x2, x3. Okay, before that, so before taking square, we find again adding row wise also. Why? Because this is two-way classification. So we adding row wise also. Okay, if you add these three numbers, you get minus 11. This is called what? Sum of y1 equal to minus 11. If you add these three values, you get sum of y2 equal to minus 5. Similarly, we get sum of y3 equal to 3 and sum of y4 equal to minus 22. Okay, if we add these four values, you get minus 35. At the same time, if we add these three values, you should get the same value. Once you get adding both row wise and column wise, we get same value. Then only your data is correct. Otherwise, your data is what wrong. Okay, so if we add column wise and row wise, you get minus 35. Once you complete this portion, next, taking square of x1 and x2, x3 square. Why? Because we want to find the sum of square of total value. That's why we are finding x1, x2, x1 square, x2 square, x3 square. What is x1 square? Minus 5 square equal to 25. Minus 3 square 9. Minus 2 square 4. Minus 8 square 64. After that, adding this 4 value, you get sum of x1 square equal to 102. Similarly, we get these 4 values. After that, adding this 4 value, you get sum of x2 square equal to 232, 234, and sum of x3 square equal to 31. Okay, once you complete a table values, then we go for a step by step. Okay, what is step number one? Step number one, first we define null hypothesis and alternative hypothesis. Usually, we consider null hypothesis is H naught and alternative hypothesis we consider H1. Okay. So here H naught is what? There is no significant difference between the column and between the row. So here column we consider engine, row we consider detergents. H1 is alternative statement, which means negation statement of H naught. So there is significant difference between the engine and between the detergents. So this is called step number one. Step number two. What is step number two? We write level of significance. Okay. From this problem, the given level of significance is 1%. So we can write 0.01. Okay. What is step number three? To find a variance ratio value, that means F value. If you want to find F, first we will find a one what is n value, what is t value, what is correction factor value, one by one. Later we find a F value. Okay, so first I am going to find n is nothing but number of observation, which means number of given observation. We get 12. For example, we see this is our data. In this data we have only 12 values. Okay, column wise three columns are there. So each column we have four values. So 4 plus 4 plus 4, 12. Next we find a t. T is nothing but sum of all the observation, which means if we add this 12 value, we get minus 35. Okay. So sum of all observation equal to minus 35. Next we find the C. C is what? C means number of columns. Okay. From the given data, we have three columns are there. One is x1, another one is x2, another one is x3. So C equal to number of columns, that is 3. Next we find R. R means number of rows. Okay, from the given data, we have 4 rows are there. 1, 2, 3, 4. Each row having 3 elements. 1, 2, 3. Okay. Each column having what? 4 elements. Okay. So this is two-way classification. In two-way classification, there are two different kind of problems satisfied. One is rows and columns are equal. Second one is rows and columns are not equal. Okay, so we can apply both type of problem by using what randomized block design. Okay, next I'm going to find the correction factor. What is correction factor? T square by n. We know t value minus 35. Taking minus 35 square by 12 using calculator, we get 102.08. Okay. So next I'm going to find a SST. What is mean by SST? Sum of square of total value. Okay. What is sum of square of total value formula? Sum of xi square minus correction factor. So from this problem, we have three square term is that sum of x1 square plus sum of x2 square plus sum of x3 square. What is sum of x1 square value? 102 plus 234 plus 31 minus correction factor value. After simplification, we get SST equal to 264.92. Next, we find a SSC. SSC is nothing but sum of square of column wise. Okay. So we know sum of square of column is nothing but sum of x1 square by n1, sum of x2 square by n2, sum of x3 square by n3 minus correction factor. So here, what is n1? N1 is nothing but sample size in treatment A. Okay, that means engine 1. Sample size in engine 2. Sample size in engine 3. Okay. So you see data x1 value. Sum of x1 value is minus 18. So minus 18 square. N1, how many values are there? 4 values are there. Here also 4, here also 4. Therefore, N1 equal to N2 equal to N3 equal to what? 4. So we get this one. Okay. So after simplification, we get 135.17. Next, we find SSR. SSR is nothing but what? Sum of square of row wise. What is row wise? Row wise, we consider same formula, but an operate notation is what? Different. Sum of y1 square by n1, sum of y2 square by n2, sum of y3 square by n3. Yeah, in this problem, we have 4 rows are there. So we write 4 times minus correction factor. So listen very carefully. So here n1, this n1 is sample size, but we have different meaning. These sample size are column wise. These sample size are what? In row wise. Okay. You see from the given data, sum of y1 square value minus 11 by n1. N1 is nothing but total sample size in row wise. In first row, how many sample size is there? 3 size is there. So 3. Second row also 3. Third row also 3. Fourth row also 3. So that sample size in row wise, previous one is sample size in column wise. So after simplification, we get SSR equal to 110.92. Okay. So next we find SSE. What is meant by SSE? Sum of square of error, that is equal to subtracting from total column and row. Okay, so SST minus SSC minus SSR. SST value 264.92 minus 135.17 minus 110.92. After simplification, we get 18.83. Now we write ANOVA table. Okay, so therefore the ANOVA table is, we consider 5 different categories. Source of variation, sum of square, degree of freedom, mean square, variance ratio. Okay, so first we write between column SSC value 135.7, SSR, this is sum of square of error value, and this is called sum of square of total value. If you add these 3 value, you get same value. Okay. Next, I am going to find a degree of freedom. Degree of freedom in column wise is C minus 1 formula. Number of column, we have 3 columns. So 3 minus 1, 2. Similarly, we get R minus 1. That is nothing but row wise. So we have totally 4 row. So 4 minus 1 equal to 3. Within errors means we multiply row into column, which means C minus 1 into R minus 1. We get 2 into 3, 6. Okay, total value is nothing but you first you simplify this, then adding these 3 value, you get 11. Otherwise, 1. Okay. R, we have 4 R value is 4. Column is what? We have 3. So 3 into 4, 12. 12 minus 1, 11. Okay. Next, we are going to find the mean square between column, mean square between rows, mean square within errors. Okay. So what is mean square column formula? Sum of square of column by degree of freedom. That means this number by this number, 135.17 by 2 equal to 67.585. Similarly, we get MSR value. MSR is nothing but SSR by R minus 1. We get 36.97. Similarly, we find MSC. MSC is nothing but SSC by degree of freedom. So we get 3.14. Okay. Next, we find a variance ratio. What is, listen very carefully, what is difference between ANOVA test 1 and ANOVA test 2 means, in ANOVA test 1 we are discussing only between column. In ANOVA test 2 we consider both between columns and the rows. So that variance ratio also we find 2 times. One is column wise, another one is row wise. Okay, so what is column wise formula? FC equal to MSC by MSR, otherwise MSR by MSC. Listen very carefully. Your variance ratio test always what? It should be greater than 1. We should not get less than 1. So that numerator value always highest value comparing to another one. Okay. So here 67.585. Here you see error value 3.14. So you consider this is numerator, this is denominator. So we get 21.52 if MSC greater than MSC. Similarly, we find degree of freedom for this. What is degree of freedom for this? C minus 1 comma this number. So we get a 2 comma 6. by using statistical table, we get 10.92. Okay. Next, we find the variance ratio in row wise. What is formula? FR equal to MSR by MSC. MSR value 36, MSC value 3. So obviously, we get numerator value is what? Highest value. Then only we get greater than 1, 11.77. Similarly, we find degree of freedom for these two, which means what 3 comma 6. By using statistical table value we get 9.78. Next we go for step number 4. What is step number 4? We write the critical value at 1% level of significance of degree of freedom in column wise is 10.92. Similarly we write a critical value at 1% level of significance of degree of freedom 3 comma 6 equal to 9.78. Next, step number 5. Step number 5, we write conclusion for 2 times. One is conclusion for column wise, another one is conclusion for row wise. Okay. How to write conclusion? First, we write but obtained value is strictly less than table value, then given statement is accepted, otherwise rejected. Suppose, for example, you see, uh, for example, we see this problem. The computed value is obtained, which means obtained value is what? In column wise, 21.52. Table value is 10.92. So obviously it is greater than. Therefore, the given statement is called what? Rejected. Okay. Why? Because H0 is rejected, H1 is accepted. What is H1? There is a significant difference between what models and engines and the what detergents. Okay. Similarly, we write one more conclusion for row wise. So what is obtained value in row wise? 11.3077. It is greater than table value. Table value is 9.78. So in this problem, both column and row wise what? We reject the null hypothesis. Therefore, H0 is rejected and H1 is accepted. What so which means what is H1? Therefore, there is a significant difference between the engines and between the detergents. Okay. So I hope you are enjoying this session. Thank you.